Welcome you all. Today we continue our previous articles where we discuss the continuous random variable. Now today we start discussing probability models. Models of derived random variable. So this is your article 3.7. Now for this one, let's look at theorem. Theorem is 3.19. So theorem says that if y is equal to Ex, where a is a scalar greater than 0, then y has Cdf and PDF. So because y is a derived random variable, so Cdf of y is equal to Cdf of x, where y divided by a. Okay. Similarly, if we look at the PDF of y, so for PDF it is equal to 1 over a times PDF of x, where y divided by a. So this is the theorem that give us the relation between derived random variable for continuous and random variable. Now there is another theorem, that is theorem 3.20, and theorem says that y is equal to ax if this is the case, and where the same condition a is greater than 0. So there are few conditions that happen. First one, if x is uniform on B and C, then y is also uniform. Only difference is here is AB times AC. Now B1, if x is exponential, if x is exponential, say lambda, then y is exponential that is lambda by a. C, if x is at long, that is n lambda, then y is at long n lambda by a. And last one is if x is Gaussian, then y is Gaussian with a mu and a sigma. So this is a very simple relation when we have a scalar multiplication. So what about, there's another theorem, what about addition? So if the derived random variable y is equal to x plus b, so in that case Cdf of y is equal to Cdf of x, where y minus b. Similarly for PDF, of y is equal to, you have to know the PDF of x and just plug in instead of x equal to y minus b. So, okay. Now let's do an example here. So example is 3.24, and example says that let x be a random variable with CDF f of x, let y be the output of a clipping circuit with the characteristics y is equal to g of x. So we have y is equal to g of x, and that is defined as 1 when x is less than or equal to 0, and 3 when x is greater than 0. So this is the phenomena. Now we have to find CDF of y and also PDF of y. Now okay, now to find this thing, how we do that? So we say that CDF of y at 1 is equal to probability of capital Y is less than 1. So this is the definition of CDF. So this is equal to, if we look at the relation from here, it is equal to x less than, so it is equal to probability that x is less than or equal to 0, or in other words is equal to f x of 0. Similarly, for y equal to 3, x is greater than 3. Okay, now if we look at the CDF, that f of x of 0 at y equal to 1. Now CDF have a jump because there are only two values, either 3 or 1 or 3, so this implies that when y is greater than or equal to 3, in that case this must be equal to 1. So PDF of y is 0, is fx of 0, and is 1. Okay, so 0 when y is less than 1. So if y is less than 1 and is less than 3, in that case this is fx 0. But at 3, because there is a clipping circuit, so at 3 there is a jump and it says that y is greater than or equal to 3. So this is the way we can write the PDF. Now CDF, sorry. Now let's write the PDF. So for PDF, because there are two jumps, at one is at y is equal to 1 and other is at y is equal to 3. So there are two jumps at y is equal to 1 and y is equal to 3. So this implies that PDF of y is equal to f x of 0 delta at y minus 1 plus 1 minus fx of 0, that gives the value equal to delta minus 3. So this way we can easily calculate the PDF and CDF of derived random variable. Now to further look another example to clarify ourselves. So this is another example where we have the output voltage of a microphone is a Gaussian random variable V with expected value 0 and standard deviation 5. So we have a random variable which has expected value, random variable V with expected value mu of V and sigma of V is equal to V of 0 and 5. Now the microvolts signal is input to a limiter circuit with cutoff value is plus minus 10. So means that if so there's a circuit, we say W is a limiter. If you give voltage to this circuit, it has limit values. One is minus 10, other is 10. In between you have a voltage. So minus 10 when V is less than minus 10. Otherwise, if you are in this range of the voltage, that is between 10, you have the same output. But above and below 10 is fixed, so you have a limiter defined. Now we have to find the CDF and PDF of this derived random variable. Now CDF. So we know that the CDF is when W is less than minus 10, so it is 0 because of the limiter. And we know that when W is greater than 10, you have 1. Okay, so this is the basic idea. Now because this what we know, but we have in between the range that is defined by the this voltage. So for this range, that is between minus 10 W to 10, this is the range that defined by this Gaussian. So for that Gaussian, if we manipulate the Gaussian, so we know that it is with the voltage 0 and 5, so we have a jump at minus 10, okay, and jump at 10. So how we write this? So we can say that, okay, because we have to relate probability of W, that is equal to probability of W is less than small w, that is actually equal to probability of V less than W, that is equal to probability of V of W. Okay. Now as V is a Gaussian with 0 and 5, if we look at theorem 3.14, that means that FV of V is equal to, if I look at the standard norm, we have to divide by 5, so V by 5. So this implies that this is equal to phi of W by 5, because in that case we have the same probability. So this is the CDF. For PDF you have to just take the derivative and you just plug in the values. For CDF, for PDF from the CDF, it just take the derivative. Let me write on. When I take the derivative of minus 10, it is 0. When I take the derivative of 10, it is also 0. Now I have to take the derivative for these values. So when it is equal to minus 10, then so I have to take the derivative at these limits and in between the limit. Okay, in between we have the Gaussian. So we have to take the derivative at phi of W by 5 when W is minus 10. Then I have to take the derivative W by 5 when we have minus 10 w and 10. Then I have to take the derivative of w of 5 when we have w, but in this case w equal to 10. Okay, so now we move to next one. So as we know that phi of minus 10 divided by 5 at w is equal to minus 10 is equal to 0.023. Now similarly we have phi at 10 divided by 5, that is equal to 0.977. So now for remaining I have to take the derivative of the standard Gaussian, that is phi over 5. I have to take the derivative, that come out to be 1 over 5 under root 2 pi exponential minus omega square by 50 for minus 10. So this implies that PDF of W is equal to derivative of PDF of W. When we plug in the values, it becomes 0.023 delta W plus 10, and W is equal to minus 10, and we have 1 over 5 under root 2 pi exponential minus omega square by 50 when you are in between this range. After that you have point 97 delta omega minus 10 when W is equal to 10, 0 otherwise. Now let's do another example. 3.26. This example says suppose X is a uniform distribution over X is a uniform distributed over interval is given, that is minus 1 and 3, and we have derived random variable y is equal to x square. Now we have to find CDF of y and PDF of y. Now because we know that if we write the PDF of uniform random variable, so it look like 1 by 4 0 minus 1 0 otherwise. Now CDF of y is equal to actually probability of x square is less than equal to small y. That can be written as probability of minus under root y is less than equal to root y. So this is the relation that we have to calculate. So or we can calculate this probability by taking the integration. of x of x dx. If we do that, we easily find that that come out to be y by 2. So now this is the relation when we are within the range of -1 and 3. So now we have to counter the relation when we are at -1, and we will, but not equal to 3. Okay. So, or in other words, if we look at from 0 to 1, so this is the relation. But if we look at from 1 to onward, how we solve the problem? So for next, we have to solve the CDF when we are starting from -1 and goes up to under root y. 1 by 4 dx, it becomes under root y plus 1 divided by 4. Now if I, when as we know that y is equal to x square, when y is x is 3, y is equal to 9. In that case, CDF at CDF is 1. Okay. When y is greater than or equal to 9. Now if I write the CDF of y equal to 0 under root y divided by 2 is under root y plus 1 divided by 4 and is 1. So if we look at, this is the relation when y is less than 0. This is the relation when we start y is from 0 and 1. And then we look at from 1 to 9. And when it is greater than or equal to 9. So this is the CDF. Now for PDF is very simple. Take the derivative. For PDF, if I took the derivative, so I come up with 1 by 4 under root y. We have 1 by 8 under root y. And we have 0 otherwise. So we have to plug the relation, that is 0 y 1. And then 1 to 9. Now let's do a quiz, and quiz is 3.7. And quiz says that we have a random variable x has the probability density function. So probability density function of x is given to us. This is 1 minus x divided by 2, 0. This is the range when x is between 0 and 2, 0 otherwise. Now we have a hard limiter that says that y values must be equal to x. So this is only possible, it is equal to x when x is less than or equal to 1, and is 1 when x is greater than 1. Now question 1 is find find the CDF. Now, as you know that the CDF of x is calculated by taking the integration, that is equal to minus infinity to x f x of say y dy. Now when we do that, this becomes minus, because it starts from 0, so put 0, goes up to x. So from 0 to x it becomes 1 minus y by 2 dy. When we do that, so we can solve it easily. It becomes x minus x squared divided by 4. So this is the CDF for this one. When it is greater than or equal to 2, it becomes 1, because this is the definition of CDF. So this implies that CDF of x is equal to 0 when x is less than 0, and x minus x squared by 4, and 1 when x is greater than 2. So here you have to put the range, that is from 0 to 2. Now this is the first part that it is asked to us. Now the second one question is to calculate the probability when y is equal to 1. Now probability for y is equal to 1, this is actually, if we look at the relation for y is equal to 1, we have this thing, that x is greater than 1. So this is equal to probability of, from this relation, is x is greater than 1. Or we can say the probability of 1 minus x is less than or equal to 1. This is the definition of CDF, so it becomes 1 minus CDF of x of 1. So CDF at x of 1 is 1 minus 1 squared divided by 2. So when we plug in the value, it becomes 1 minus 3 by 4. When we solve it, it becomes 1 by 4. Okay, how we do that? We just plug in 1 here, so it becomes 1 minus 1 by 4. When we solve it, it becomes 3 by 4. We put here. Now the next part is asking from this quiz is the third one, and it says, what is the CDF of y? Now for CDF of y, as we know that CDF of y is 0 when y is less than 0. Okay, because it's not defined. Now we also know that CDF of y is equal to 1 when y is greater than 1 or equal to 1. Okay, these two limits we know from the definition of the y. Now in between we have to calculate the definition. So we have the range left, so we have to find the probability of y, that is equal to probability of y is less than small y, that is equal to fx of y from the definition, and this is only applicable when y is between 0 and 1. Now if you look at, so because they are the same, so this means that probability of y, CDF of y is equal to 0 when y is less than 0. Otherwise it is equal to fx of y. So if you look at the CDF of y, it becomes y minus y square divided by 4. when we are in between 0 and 1, and it is greater than or equal to 1, it is 1. So this is the definition. Now fourth part is the last one for this quiz. What is PDF? Now we calculate the CDF. Now the point is to calculate the PDF, and we know that it's very simple. Just take the derivative of the CDF. Now PDF of y, so we have to take the derivative with respect to y of this thing. That becomes 1 minus y divided by 2. Okay, so plus when we put 1 here, okay, so it becomes 1 by 4 we just plug in the values and it becomes 1 by 4. Okay, so for equal to 1 is 1 by 4. For 1, so we just know that it is equal to 1 by 4. We have to take this limit for equal to 1. So we have 1 by 4. Now we have to multiply with delta, that is y minus 1, because at this point we have a jump. Okay, so this is only possible when q r is between 0 and 1. Otherwise your values is 0. So this is the PDF that we can calculate. Now the last topic of this chapter is article 3.8, and this is conditional. Continuous random variable. So how we look like if there's a conditional. So by definition 3.15 says conditional PDF given an event. So just go through it very simply. It is the same one. We have a PDF of x condition with p is equal to, similarly as we discussed in discrete case, that you have to find the PDF of x divided by probability of b. This is only possible when x belongs to b and 0 otherwise. So this is known as conditional PDF. So similarly we have another theorem here, 3.23, and it says that given an event, so if there's an event space, so that has a partition B's given to you, and the conditional PDF, that is f(x) of b then if I calculate the PDF of x, this can be equal to sum all the conditional PDFs with the event space and multiply by its probability. Now there's one more definition, and definition is 3.16. So it is the same extension as we discussed in the discrete set. So conditional expected value given an event. Now expected value, that is a conditional one, is equal to, it depends upon the PDF, so just multiply with the conditional PDF, so that's it. So it's simple as that. You can calculate the conditional expected value. Now let's do a quiz and to conclude this chapter. This is quiz 3.8, and quiz says that the probability density function of random variable y is given to us, and it says it is 1 by 10 and 0 otherwise. So 1 by 10 is between 0 and 10, and 0 otherwise. This is given to us, and he says find the following. So first one is asking us to find the probability when capital Y is less than or equal to 6. So of course this is can be calculated using the PDF by taking the integral from -infinity to 6 fy of y dy. So this is the formula. Just plug in the values. So from, because it is start from 0, so we put 0 to 6, so put 6 here and plug in the values, that is 1 by 10, and do the mathematics, take the integral and plug in the values, so it becomes 0.6. Now the second part, he is asking to calculate the conditional. Now we have to find the conditional PDF for y is less than 6 of y. Now we know the formula, that is equal to, we have to write the PDF of y, we have to divide the probability y is less than 6 and 0 otherwise. Okay, so this is the formula. So just plug in the values and divide it, so it becomes so just divide by 0.6, so, and the probability of y is 10, so it becomes 1 by 6. 1 by 6 when we are in the range of 0 and 6, and 0 otherwise. Now the third one I just wrote here. Third question is find the probability when y is greater than 8. So this can be written as 1 minus probability when y is less than or equal to 8, or it can be 1 minus f from -infinity to 8 fy of y dy. So we just solve it, so it becomes 0.8, it is 0.2. Now the next question is fourth one, and fourth says that calculate the conditional probability for y is greater than 8 of y. So it is similar as we did in previous case, just plug in the values. Sorry about that. We have to write the event, that is 0 is less than y is less than equal to 8. 0 otherwise. When we do that, 0.2 we have to divide with 0.2, so when we put 0.2 it becomes 1 by 2. So this is only possible because this was greater than 8 by mistake. So this is y is greater than 8 and less than equal to 10. So this is the main idea. So y is between 8 and less than 10, 0 otherwise. Now question number 5. We have to find the expected value of y given y is less than equal to 6. So for expected value, I told you it's very simple. Just plug in the limits from minus to infinity multiplied by y with the conditional PDF, that is y given y is less than equal to 6 of y dy. So it will give you the answer. So when I plug in the values from 0 to 6, it becomes y by 6 dy, and I get it becomes 3. And last question is expected value of y given y is greater than 8. So just same thing, infinity to infinity y, conditional PDF of y is greater than 8 of y dy. When I plug the values, it becomes 9. So here I will stop this. So with this we conclude chapter number 3 on continuous random variable.